Dear Lord, we thank you for the gift of life today. You allow us to have another day to praise you and see your glory. Thank you for the love and protection, especially this time of pandemic. Bless us, Father, with your wisdom as we begin our class. Help us to focus our hearts and minds on what we are about to learn. Inspire us by your Holy Spirit as we think and listen. Guide us by your eternal light as we discover more about the world around us. Lord, we thank you and let your will be done in our lives. We ask all this in the mighty name of Jesus. Amen.
Okay. Okay. So first of all, no, I'd like to extend my appreciation no, sa inyong section because out of all my classes, kani siya nga section ang murag participative kayo or interactive kayo ba no? As well as naghan nga open silang camera which I appreciate no. Although dili mo siya required but I appreciate that kay para makita pud ta mo no and makita po ninyo inyong classmates ba so mura ra taog nag face to face nga discussion di ba so thank you no sa inyong participation. Okay, anyway, we are now in week 8 no of our academic calendar no for mechanics of deformable bodies. So for this session, we will just actually continue our discussion no, from previous topic which is on simple strain, di ba? So simple strain na to ang last topic and naputol lang to siya no. But for this session, our main agenda would be on statically indeterminate structures. Okay? But first of all, ako lang siguro i-turn off ako ang camera no kay earlier ano man good naka-experience mi og glitch sa ako ang internet connection murag dili niya kaya magsabay ang camera as well as ang slides no nga i-produce. So okay lang, okay lang tano nga walang siyang i-off kay para di ra kayo magputol-putol. So among gitry earlier, ano gid siya, dili gyud niya kaya especially mag computation na or sa na nako i-write sa PowerPoint. Okay? Joke. So later no I will announce your schedule for midterm examination. Okay? So anyway, for this session, again, no, we will focus on statically indeterminate structures. So when can we say that we have a statically indeterminate structures? No? So that is when if the equations of equilibrium are not sufficient to determine all the reactions on a member. So Um, this condition exists class now in structures where the reactive forces of the internal resisting forces exceed the number of independent equations of equilibrium. So when we say equations of equilibrium, that refers to our summation of wait. So thin ang ihang line. So summation of forces vertical equal to zero. Summation of forces um, on x-axis or horizontal is equal to 0 also, and your summation of moment is equal to 0, di ba? So these are our independent equations of equilibrium. So, indeterminate ang isa ka structure class if ang unknown or ang unknown variable no or entities sa to ang member is more than the available independent equations of equilibrium. So if the reaction is more than or the unknown reaction or the resisting forces is more than the available equations of equilibrium, 'di ba? So ato lang siyang gini-note as E, no? Ang independent equations of equilibrium and then reactions or resistive forces as R, no? Or as R. So therefore, your structure is statically indeterminate. Okay? So let's say for example, no? So as a for illustration purposes, let's say for example, naatay bar that is restrained, no? So, let's say for example, manetong point A and si point B and the only internal force nga nag-act is ang iyahang own weight lang, no? So, how do we find the reaction no, at point A and also your reaction at point B? For example, ano yapon siya, no? Anyway, you can have either way. So, yield lang na siya yung negative, then opposite ang iyahang true reaction, no? Okay, anyway, for this example class, no, we have how many reactions unknown. So you have two, di ba? CRA and CRB. So meaning your reaction, you have two reactions or unknown reactions, and then your available independent equations of equilibrium is only pila man ang available. Di ba isa lang? Because dili ta maka summation of forces on x-axis. So, dili ato na siya magamit kay ang ato ang forces is along vertical lang man no, or on y-axis lang siya. So, wala tayo makam up nga ang force no on x-axis. And also, you cannot sum up moment no at point A or at point B. Ano man, that is because your support is actually fixed support, no? And then recall from our statics of rigid bodies, when you have a fixed support actually has a resistance, no, to moment. So naa siya resistant to moment class or to overturning. That's why you cannot say that your summation of moment at fixed support is equal to zero. It is not equal to zero class ang imuhang moment no at fixed support. So only um pin support and hinge support no ang class ang walay resistant to moment no. So these supports kani si hinge and si pin, they don't have the capacity no to resist moment. That's why ang ato ang yung assumption always no at pin and at hinge support is summation of moment is equal to zero no at hinge and pin supports no. So they don't have resistance to moment. That's why mao na ang ato ang assumption no. So zero ang ilahang moments kay wala may ma-develop nga moment at that point. So at fixed support naa na siya ma-develop nga moment class. That's why dili na siya zero. Ha? Okay? So I hope nasabtan na siya. So meaning out of the available independent equations of equilibrium, we can only use the summation of forces vertical no equal to zero. So kanilang ato ang ma-apply din nga problem class no meaning we only have one equation of equilibrium and your R is greater than your E, di ba? So 2 is greater than 1. That's why this is an example of statically indeterminate structure class. Okay? Sige. So to to further illustrate and to further understand the concept and the fundamental principles of statically indeterminate structures, let us solve sample problems. No? So first we have here situation number 1. So you have a horizontal bar of negligible mass is hinged at A. So the bar is supported by a bronze rod, 2 meters long, and a steel rod, 1 meter long as shown. So using the data in the table, compute the stress in each rod. So you have here properties of your respective materials, 'di ba? So how do we solve for this problem ba class, no? Sige. So for a while ha, let me just add blank pages. Okay. So the problem class ask us to compute for the stress in each rod. So at steel and at bronze na to nga material. 'Di ba? Stress or the normal stress is just equal to P over A. Therefore, your normal stress for steel should be equal to PS, actual load of your steel over your cross-sectional area of steel. And similarly for bronze, no? So normal stress of bronze is just equal to your actual load at bronze and your cross-sectional area of your bronze. Sige. So meaning class, given man ang ato ang cross-sectional areas for bronze and for steel, ang ato lang yung problema ani is ang iyahang actual loads at bronze and at steel. So si PB and si PS. So how do we find PB and PS? So sige. So for this um structure class you have, so if ato ni siyang putulon, so magawas din ha ang iyahang internal reaction So tensile reaction ako siyang i-name as TS and TB, or the tensile force at B, or at bronze rather. So reaction at A, so since this is hinge na siya reaction vertical since may happen sir. So for a while ha kay na ay concern ng other instructor. Anyway, so let's continue. Asa na galing nga part? So, di ba at point A, you will have a vertical reaction at A since it involves forces on y-axis, di ba? And then for the x component, wala siya force involved, Kaya wala man tayo inclined or wala tayo force on along the horizontal component, Or horizontal axis. Okay? So, wala tayo reaction horizontally. Okay? Now, ang ato ang available equations nga magamit danhi is, of course, di nanto magamit si summation of forces on x-axis, Kaya wala man tayo ma-come up nga, or wala tayo ma-sum up nga forces on x-axis. But we can actually sum up forces vertical, or on y-axis, which is just TS plus TB plus RV is equal to si 50 kilonewton, Since si 50 kilonewton naman ang downward. And also, we can sum up moment at point A. Kay it is a hinge support man. So we can say that summation of moment at point A or at hinge support is equal to 0, Then we'll have TSTB and 50 kilonewton lang dayon nga consideration no nga forces or ang involved nga forces rather since your RV will be equal to zero kay at point A man na siya nga reaction and when you sum up moment at point A mag zero lang na siya, di ba? Okay. So, sige. Unsa man na to ang gamiton ani no? So, if mag sum up forces ta vertical class no or on y-axis, mas ano siya, lisod siya since mag-introduce ta og three unknown variables, no? We have kung summation of forces on y-axis, di ba ma-involve man si RV, TS, TB, and si 50 kilonewton. And from that equation, you'll have three unknown variables. Unless if mag-summation lang of moment at point A, ang ma-involve lang is si 50 kilonewton, TB, and si TS, no? In which, ang ato ang goal is to determine TB and TS, di ba? Kaya mo na silang PB and si PS. So, dili na necessary nga pangitaon pa nato si RV. Kay wala man po siya gipangutana sa problem, no? Unless nga gipangutana siya, then pwede na to siya i-determine, no? But for this sample problem, let us consider the summation of moment at point A equal to zero, having counterclockwise as positive. So, 50 kilonewton will create a clockwise rotation no, with respect to A. So, meaning that will be negative 50 times moment arm nga 0.80 meters plus 1 meter plus zero point 0.6. So 0.6 plus zero point 0.8 is 1.4. No? Then plus 1, so 2.4 meter. So, ako lang i-rewrite. So, pangit Japon. Na lang, murag 50 pa siya, murag 80 ka ganina. Anyway, so after 50 kilonewton, ang sa pamailain involved na force, no? So si TB, di ba? So TB will create a counterclockwise rotation no, with respect to point A. So meaning, it will have a positive sign convention. So plus TB times the moment arm. No? So TB to point A is 1.6, no? 0.6 plus 1 meter lang. Plus, so TS will also create a counterclockwise rotation with respect to point A. Therefore, that is positive yung sign convention, no? And multiplied by the moment arm nga 0.6. So plus TS times 0.6 equal now to 0. Since wala na may lain force involved, di ba? Sige. So, let us just separate them, no? Ang ato ang equation. So let's combine like terms. So left side sa ato equation will contain the unknown variables and then ang right side sa ato equation will contain the constant, no? So in this case, this is 1.6 TB plus 0.6 TS is equal to, so ato lang i-transpose, no? Si 50 times 2.4 and that will be positive na dayon. So how much is, ano class, 50 times 2.4? Kindly compute. So you can actually unmute yourself, no? Okay, thank you. Kay para mas dali na ako ma-receive ang inyong feedback. Kay basin mag-chat mo, di na ako ma-notice. Kay dili siya ga-notify.
120, sir.
Sige. So meaning, we have this first equation, di ba? So you have 1.6 TB plus 0.6 TS is equal to 120. Okay. Sige. So, more na ato ang makuha ang equation class, no? Kung ang equation of equilibrium lang ato ang basihan. That's why we need additional equations, no? So, this is actually statically indeterminate structure. Therefore, we need additional equations. And those additional equation is actually called equation of compatibility. Okay? So, ang tawag niya ana is equation of compatibility. And how do we find or how do we create or relate no equations for compatibility? So, it is by relating the geometric relation of your deformation, no, of the deformation of our structure class. So meaning, if deformation ato ang basihan, no? So consider nga ato ni siyang na siya load 50 kilonewton, no? Then it will create a deformation with respect to this ano class, no? Um, deformation, di ba? Sige, so ako lang na siyang i-draw sa another space. Sige, so if this is the original bar, then as siya load 50 kilonewton, 'di ba? It will deform in this manner, class. Okay? And from original bar, from point A to PS, excuse me, you have point 0.6, 'di ba? So this is your TS. And then from TS up to TB, you have 1 meter now. And then 0.8 meters. No? Tama ba? Okay, so TB, TS, then si 50 kilonewton nga weight. So meaning class, from this point to mo iyahang original point, diba? If mo deform siya ani nga manner, therefore mabinat na siya class, no, ma-elongate na siya. And this elongation is our deformation, no, in steel and our deformation for bronze. Okay? So from the given geometric figure, we can actually create a relationship, no? So unsa man nato ang makuha ana. So these are triangles, di ba? So ratio and proportion lang class, di ba? So your deformation of steel over 0.60 is equal to, so from small triangle is equal to your big triangle nga kani siya nga triangle. Okay? So deformation of steel is over 0.60 is equal to your deformation sa inyong bronze over the base, no, sa imong triangle, na big triangle, so 1.6 meters. Therefore, 1.6 deformation of steel is equal to 0.6 deformation of bronze, no? So we have this relationship class between your elongation. Okay? Sige. So next, sa man nato ni Ron. We now have this relationship, diba, of your deformation for your steel and for your bronze. So ato sang i-analyze, no? I-analyze po nato ato ang material individually. Sige. So for the deformation of your steel, so diba that is just PL or PSLS over your cross-sectional area of steel and your modulus of elasticity for steel. So your deformation of steel would now be equal to, so how much is PS nato is, di ba mo na siya ato ang axial load or tensile resistive force on steel or CTS times your original length of steel, pila to? 1 meter. And then your cross-sectional area for steel is 600 millimeters squared, no? And modulus of elasticity for steel is 200 GPa or gigapascal. Okay, so before we proceed, no, let me just clarify or let me just inform you, no, for those wala pa naka-discover, no, that MPa is actually equal to Mn or meganewton per meter squared. Or it could also mean Newton per millimeter squared. Okay? So, ano siya class, no? So, meaning, if you have length, no, in meter, so, ang imong ipares dapat ana is in Newton, no, ang force. And also, if naka-Newton na imong force, pwede po nyo siya parisan og naka-millimeter nga length, no? So, you have to be consistent lang. But, di mo pwede isagol si kilonewton and millimeter. Okay? So, maglibog na yung discrepancy sa imuhang answer ana class. Okay. So, ato lang ni siyang i-adapt, no? Kay mas easier if, or mas convenient for us to convert si meter na lang, no? So, 1 meter is, di ba, 1,000 millimeter. So, this is in terms of millimeter na. Then, area, cross-sectional area of steel is pila to? 600 millimeter squared. So 600, this is mm squared times the modulus of elasticity of steel. So 200 gigapascal, di ba? So take note that we are in gigapascal nga unit and if ato na siyang i-convert into MPa, move lang taog 3 decimal place, di ba? So times 10 to the power of 3. So this is now in MPa, no? Or MPa, or ato siya i-breakdown, it will have, di ba, unit nga, and per mm squared. So, makancel, ang remaining or resulting unit would be in millimeter per Newton. So, kindly solve for this class. So, 1,000 divided by 600 times 200 times 10 to the power of 3. So, pila man na siya. So, deformation of steel is equal to, in terms of TS, no? So, ato siyang gi-express in terms of TS. Zero? Ano, ano man, nag-zero? Kanilang class of i-compute, i-input sa inyong calculator, 1,000 divided by 600 times 200 times 10 to the power of 3. So we have here 8.333 times 10 to the power of negative 6. Sige. Or wala siya maigo. Times 10 to the power of negative 6 TS. Diba? Taylor Swift. Okay. Now, for bronze also, ato po siyang i-solve, no, individually. So, PBLB over AB, EB equal now to how much is the length of bronze, no? So, PB is just our TB, no? Then, length of bronze is 2 meters, di ba? Sige. So, ato lang yapon i-express in terms of millimeters. So, 2,000 all over cross-sectional area of your bronze is 300 millimeters squared times the modulus of elasticity for bronze, which is 83. Again, it is in gigapascal, so move to 3 decimal places para mag megapascal, and in order for our units to be uniform, no, or compatible with each other. So the formation of bronze is equal to, in terms of TB, no? Pila man ni class? So you have 8.032 times 10 to the power of negative 5. Sige, so 8.032 times 10 to the power of negative 5 TB, no? Okay. Now, di ba we have this relationship, no, that the deformation of your steel is 1.6, no, equal to 0.60 of the deformation of your bronze. Okay? So, ato lang na siyang i-substitute sa to ang equation. So, you have here, di ba, kato? 1.6 deformation of steel is equal to 0.6 deformation of bronze. Then, substituting the expression, no, for deformation of steel and bronze. So, 1.6 times the deformation of steel, 8.33 times 10 to the power of negative, pila to? 6, no? PS is equal to 0.6 of deformation of bronze, no? Nga 8.032 times 10 to the power of negative 5 TB, no? Sige. So, let us just express TS, no? In terms of TB. So, meaning, TS is 0.60 times 8.032 times 10 to the power of negative 5 all over 1.6 times 8.333 times 10 to the power of negative 6 TB. So, what is the relationship na of TS in terms of TB? So, TS is how much class? 3.615 TB. So, we have related, no, the actual load of steel and the actual load of your bronze. Sige. So, next step, and this is our second equation. So, substitute equation 2 to our equation number 1. Diba? We have this equation 1. So, if i-substitute na to ang TS, no, here, sa atong equation, and di ba, naka-express man to ato ang TS in terms of TB, therefore, the resulting equation would be, ano na lang, one ang unknown variable, which is si TB. Di ba? Then, we can directly solve for TB na dayon. Okay? So, substitute, next page na lang na para dili libog ang space. So, substitute equation 2 to equation 1. So, ganito ang equation 1. 1.6 TB plus 0.6 TS is equal to 120. 1.6 TB plus 0.6 TS, which is TS is 3.615 of TB, is equal to 120. Diba? So, kindly solve class, no? Ma-shift solve na lang man kay isa na lang man ang unknown variable. Therefore, TB is how much? So, notice, no, nga, these are actually in newtons, no? Or in newton. Kay ato man gigamit there is MPa, di ba? Newton and millimeters. So meaning your 120 here, di ba nakakilo newton ni siya? So i-express nimo siya in newton also. So times 10 to the power of 3. So how much is TB? TB? 31,838.68. So this is in newton, 'di ba? And if ato siya i-convert into kilonewton, so that is just 31.838, no, or 839 kN. Excuse me. Okay, excuse me. Now, we have obtained the value, no, for our actual load for bronze, no, or CTB. So to find TS, di ba we have this equation number 2? Then, i-substitute lang nato atong obtain value for TB. Therefore, ma-obtain na po nato si TS. Diba? So, TS is just 3.615 of TB, which is in um, kilonewton na lang ako i-consider, no? So, how much is TS? So, 115.098 kilonewton, no? Since naka-KN man ta. Now, nakuha na nato ang TS and TB, no? Sa ganito, ang ato alang problema is si TB and si TS, no? Kani sila. Therefore, we can now finally solve for the normal stress, no? Nga na-develop, no? At each material. So, for steel, di ba, it is just TS over cross-sectional area of steel. So, TS, you have 115.098 kilonewton. So, ato siyang express in terms of newton over cross-sectional area of steel. How much? 600 millimeter squared, no? So meaning you have unit Newton per mm squared. So the resulting unit would be in MPa. Okay? So how much is this class? 191.83. 191.83 MPa. So this is now our final answer, no, for the stress, no, developed in steel. Now, how about for the bronze? So TB over AB lang, no? And how much is TB? You have 31,838.68 Newton divided by cross-sectional area of bronze nga 300 millimeter squared. Therefore, how much is your normal stress at bronze? So 106.129 MPa. Sige. Okay, so these are our final answers, no, for situation number 1 class. Determine, sa tong question, compute the stress rather, no? Compute the stress in each rod. So therefore, the stresses, no, in steel and in bronze are 191.83 megapascal and 106.129 megapascal respectively. Questions so far or clarifications? Walay pangunta na class, so nasabtan?
Yes, sir.
Okay, so I hope ha, nasabtan. So for a while lang, mag-iyan sa akong tubig. Gamay lang class sa akin, murag gutom jud kayo.
Take your time, sir.
Wait lang. So, break sa
Well,
5 minutes.
Sir, nga na, yun usually kataas ang mga solution na ina nga problem, sir.
Kani siya, no? So, taas na mo ani. Actually, di pa ni siya mao. Dapat mas taas ani nga mga problems, no? Depende na siya sa analysis and sa inyong approach sa inyong solution class pa. But, maanad na mo. Kay pag-as yun ang ato ang solution class, nga isa ka problem nga, isa ka one whole one paper long ha, ang solution. So, when you go sa ato ang higher structural subjects, so expect yun nga back to back, isa ra naka-problem class. Di na siya whole quiz. Isa lang naka-problem ang inyong one whole sheet of long bond paper or newspaper, news print. Newsprint ba yung gagamiton?
Dili, sir.
Bond
Katong
paper man.
yellow pad. Ay, dato, bond paper.
Sir, ka na.
Sensor ka.
Wala pa
Magamit,
na heart attack, ani, sir.
sir, magamit niya siya sa trabaho, sir ba? Yes, actually, class. Gamit kayo yun niya siya, class. This will help you analyze structures. No? So, when you indulge or when you pursue a structural engineering specialized profession, then grabe yun siya ka-useful class, no? And napo ni siya other use, no, sa atong ang other fields. So, magamit yun ni siya class. Abi ni compute lang, but actually, um, useful kaayo ni siya class, especially pag abot niyo sa inyong structural design ng mga subjects. So, sa design, of course, mag-design mo ng structure. So, structure meaning, pwede building, pwede pavement, no? Pwede bridge. So, ana lang. Gusto na ko mahimong semento.
sir, ang Taylor Swift, ra mo madumduman yun, sir.
Same. Si PS. PS. PS is equal to Taylor Swift. Na masayop yun mga nasa exam class. Murag kabantay ko nga sa inyong section kay gutomon ko kay I think because of my schedule siguro sa setup sa
Lami,
akong
guro,
schedule.
mi diri, sir, kay
Ayan. Let's,
malami nga naman.
Ang paras.
Simba ko. Hapit mangumpisa na ta class kay Holy Week na hapit, no? April. Kaya sa ganitong Holy Week,
April 4 to 11.
Yes, no? So, ang
May klase yan na, sir.
mapasar. Actually, wala, no? So, ako na lang i-announce daan that our midterm examination, ang schedule niya is, ang schedule nato, no? Is on April 8. Sa Friday na siya, no? Friday, next week. April 8 at 8 o'clock a.m. until 12 p.m. So half day siya, no? Whole morning ang inyong exam on mechanics of deformable body. So 4 hours na siya ka-exam. Okay? And then um the schedule for midterm examination is April 4 to April 13 siya, no? Sa to ang academic calendar. Meaning, it will have a duration of 1 week and a half, no? Or half siya sa week, no? So 1 week and a half, 1.5 week kakibali iyang duration. And then on April 14, that is Holy Thursday already, no? So wala tayo klase ana kay holiday man na siya. So meaning, um, we will not see each other, no, for 2 weeks, no, of April. So midterm exam and April 11 to April 16 nga week dili punta magkita since um that is extension sa inyong midterm exam and Holy Week man na siya nga week, no. So we will see each other again on April 18. So meaning sa April nga month class twice ra ta mag-meet, April 18 and April 25. Okay? So kindly take note of those important dates.
Yes, sir. Ay, katong imong activities, ay imong PAT, sir, ba? Dugangan pa to nimong activity, sir, or last week?
Supposedly, ako ihatag nga assignment sa inyo no kay
Wow.
taas-taas man ang inyong murag vacation. But actually, dili na siya included sa inyong PIT for midterm. Kay it would be unfair man pod on your side nga. Karon pa na ako gihatag. Then, ang due no sa inyong PIT is on April 4 at 12 noon. So, maghatag kog assignment but dili siya included sa inyong PIT nga output. So meaning ang ato ang PIT is unsa man quiz 1, quiz 2 and assignment or seatwork 1 no and seatwork 2. I mean seatwork 1. I know seatwork 1 and assignment 1 kay assignment 1 man ta akong ihatag man to seatwork 1. Anyway, same naman sila og weight sa inyong grading system.
Extended ang deadline, sir.
Ang
Ang deadline.
ay dili na actually. Kay ang inyong pong grade no midterm grade napod may deadline and it would be on April sige lang wala pa siya na final but actually dapat after midterms maka-generate na ko sa inyong grades para ma-post ako siya sa Prism kay napod may deadline class no so dili lang kamo ang naay deadline napod may deadline so mo to siya no so maglisod ko og check sa inyo ang output if i-extend pa nako ang deadline. So that is also my purpose nga gi-deadline ako siya on April 4 kay para beyond April 4 wala na mo ihuna-hunaon nga PIT, no? So meaning maka-focus na mo sa inyo ang midterm exam kay midterm exam week man na siya. Okay, so let's continue na siguro.
Ano ang count, sir?
Wala. Taon sa sir.
Iwas na, sir. Lumiya na limbo to mo, sir.
So actually kuan man good ang setup sa akong schedule no for today kay whole day gid siya straight gid siya class marathon from 8 a.m. to 12 p.m. duha ka klase and then from 1 p.m. until 5 p.m. pod no. So ang inyong section ako ang last class for today and gutom gid siya kay marathon. Anyway, continue na ta. For situation number 2, we have here a rigid block of mass M is supported by 3 symmetrically spaced rods as shown. So each copper each copper rod has an area of 900 millimeters squared, and it has a modulus of elasticity equal to 120 gigapascal. And then the allowable stress for copper is 70 megapascal. For steel rod, it has an area of 1,200 millimeters squared and a modulus of elasticity of 200 gigapascal. No, and also the allowable stress for steel is 140 megapascal. So determine the largest mass M which can be supported in this system. Okay? For a while kay murag ano kaayo ang biscuit na akong gikaon is namo siya palaman kadto lang kay class kay gapilit siya sa ngipon.
Tiwasa, sir.
Okay. Sige. So, di ba we have this um, system, no? Structural member na system. Na siya duha ka copper and at the middle, it was supported by a steel rod. Sige. So, ako lang i-write ilahang properties, no? For copper, basin malibat ko later o pangita sa ilahang property ba, no? Asa to? For copper, na siya cross-sectional area equal to 900 millimeter squared. Yahang modulus of elasticity is 120 gigapascal and it has an allowable stress equal to 70 megapascal. Sige, for steel naman, we have an area of 1,200 millimeter squared and modulus of elasticity is 200 gigapascal. And then the allowable normal stress no is 140 megapascal. Sige. So how do we solve this? Okay. Um, ko lang i-prepare yung space. Sige. So if ato ning i-consider no, ang iyang free body diagram, di ba it will have this supports at both ends. It was supported by a copper. So ako lang i-denote ang actual load sa imuhang copper as P copper or PCO. And then for steel also PS. Then ashay, oopsie, wait. Oh, sige. So from this free body diagram, we can sum up forces on y-axis, no? Meaning your W is equal to 2 PCO, no? Or duha ka PCO plus PS. So we have this equation. So mo niya to ang makuha ang equation no out of the available equation of equilibrium. So dili gid siya enough class kay unknown si W, unknown si PCO and si PS. So this structural member is actually statically indeterminate, no? Kay obviously naman nga dili kaya sa to ang independent equations of equilibrium ma-solve ang reactions, no? Or ang resisting forces. Sige. So how do we solve this one? Di ba we will find additional equations to suffice our lacking or missing datas, no? So ato na siyang makita no ang iyahang equations of compatibility by relating the deflection no, of your structural member. So meaning, if mo deform ni siya, so since iya man ang gina-press, so ako lang yun siyang i-exage class no, for the purposes of illustration. So from this position, no, ni-deform siya, niabot siya diri sa ubos. So meaning, if ako ni siyang i-measure, mo na siya ato ang ginatawag nga deformation, no? Your deformation in members, copper and steel, no? And since it has uniform deformation man, from this illustration, we can say that your deformation of copper is just equal to deformation of your steel, di ba? So kung pila ang na elongate or na shrink, no? In this case na contract siya sa imuhang steel is equal po siya sa imuhang copper. Okay? Sige, so we have this relationship of your copper and steel nga deformation. Sige. Now, ato lang i-write here. Copper. Sige. So, same with the previous example ato na class no or situation, ato po siyang i-analyze individually, no? So, sige, for steel, we have deformation of steel is, di ba, PLAE or your P is your actual load for steel, which is CPS. Then length of steel, pila. So si steel is 240 millimeters no iyahang length. So I'll be using millimeters no in terms of length nimo. Then cross-sectional area of steel, pila gali ito? 1,200 millimeters squared times the modulus of elasticity of steel. So 200 gigapascal, di ba? So we are in, take note, no, we are in gigapascal. So in order for our unit to be compatible, no, or to be sync with each other, so need na to na siya i-convert into MPa. And to do that, move lang to og 3 decimal place. Excuse me. 3 decimal places, no? So this is now in terms of MPa, no? Or MPa is, di ba, N per mm squared. So mag-cancel out lang na siya. So the resulting unit would be millimeters per N, no? So how much is our deformation in steel with respect to PS, no? Pila man na siya, class?
1 times 10 to the
You
power
have
of
1
negative
times
6,
10
sir.
to the 6. Okay, sige. 1 times 10 to the power of negative 6, no? PS. Now, for copper, so same equation, no? PL over AE. So P copper, length of your copper is how much? 160 millimeters, no? Divide by the cross-sectional area of copper, nga 900 millimeters squared, times the modulus of elasticity of copper, no, nga 120 gigapascal. So again, ato siyang i-convert into megapascal. So how much now is our copper in terms of its actual load? 1.481 times 10 to the power of 6, negative 6. Sige. PCO. Okay. Now, we now have this expressions, no, or terms for copper and steel, no? Silahang deformation. So what we're going to do is ato sang i-test, no, ang ato ang steel and copper, no, if na-exceed ba siya sa iyahang allowable stress, no, since gitagaan man taog allowable stress. But first, di ba, ato sa ni siyang i-substitute So, i-express nato siya in terms of actual loads na lang. So, substitute deformation of copper sa equation and also substitute the equation of deformation of steel, no? Sa imong deformation sa steel na equation pod. So, okay, abi na ko next slide. Napaday free nga slide. Sige. So, sa ganito, di ba, they are just equal. So, i-equate lang nato siya directly, no? 1.41 or 81 rather, times 10 to the power of negative 6 PCO is equal to 1 times 10 to the power of negative 6 PS. Okay? So if atong i-express no si PCO in terms of PS, so i-divide lang siya class. So how much is PCO in terms of actual load of steel? Kung may tinuod ani class. Ay okay, kaganina ning 9 point asa man ning 9.995. So it's 0.675 PS daw, no? Sige, so 0.675 PS, no? So we have expressed PCO in terms of the actual load in steel, no? So this is our second equation. Okay? Sige. So let us solve for the allowable stresses, no? Or in this case, allowable forces, no? In each material. Sige. So, um, tari na lang. Allowable forces for copper class. Diba you have normal stress is equal to P over A. And if atong i-consider ang copper, so it's just the allowable stress no in copper, which is pila man 70 megapascal. So this is in 70 MPa is equal to PCO, then divide by the cross-sectional area of copper, which is how much? 900 millimeters, no? So MPa and millimeters, so they are compatible, no? So 900 millimeters squared. So your resulting unit would be in Newton, no? This is in Newton per mm squared, and mm squared. So mag-cancel out lang na siya. Therefore, your allowable actual load for copper is equal to pila man class? 70 times 900. So 63,000. Sige, so 63,000 Newton. Take note ha, nga mo na siya to ang allowable force for copper. How about for steel? Allowable force for steel. So PS over AS, no? Where our allowable stress for steel is equal to 140 megapascal, equal to PS over the cross-sectional area of steel. Pila to? 1,200 millimeters square. So PS therefore is how much class? Kindly calculate. So 168,000 sirado Newton, no? Okay. So these are our allowable forces, no, for copper and steel respectively. Okay. So if we will use the allowable axial load no of your copper. Di ba we have this relationship? Wait ha, let me just add another slide. Di ba PCO or your axial load of copper is equal to 0.675 of PS. So if we will use the maximum allowable force no for steel, which is 168 Newton, PS is 168,000 Newton. So how much is your force or actual load for copper? 113,400. So what does this indicate, class? No? So naka-Newton na siya. So take note, di ba, we have computed the allowable force for copper only, which is it should not exceed beyond 63,000 Newton. Meaning, in this case, kuan siya class, fail siya if ang ato ang gamiton is or atong consideration is the allowable stress in steel, no? And so meaning this is greater than the allowable axial load for copper. Therefore, use PCO equal to si 63,000 na itong gamiton class Newton. Okay? Now, for steel naman, so 0.675 PS. So we're just going to use the maximum allowable force no for copper nga si 63,000 Newton to find if okay ra ba si steel. Sige, so 63,000 is equal to 0.675 of PS. So PS therefore is equal to 63,000 divided by 0.675. So how much is your PS? 93,333.33. So you have 93,333.33 Newton. So this indicates that safe lang ang ato ang steel, no? Kay we have computed the allowable force for steel is 168,000 Newton man, no? Which is ang ato ang na-obtain nga value for actual load of steel considering the maximum force of copper is less than your allowable force for steel. So meaning, use this value. Therefore, use PS equal to 93,333.33 Newton. Okay? Now, we now have values for copper and steel, no, or the actual loads for copper and steel respectively, no. And then from our equation 1, di ba, we only need to find or we only have to determine no your actual loads for copper and steel, no. So substitute those values in equation 1, ma-obtain na nato ato ang W, no, or ang weight. So W or equation 1, from equation 1, ako na siyang i-label. From equation 1, you have W is equal to, di ba, 2 PCO daw plus PS. So, 2 times PCO is 63,000 plus PS nga 93,333.33. Therefore, how much is W? Pila man ay class? So, 219,033, 333.33 Newton. No? So, this is in Newton. Okay? But, Masa galito yung question? Determine the largest mass which can be supported. So, dili weight ang ipangita, but rather ang iyahang mass, no? And from physics, recall that weight is just equal to mass times gravity. Therefore, your mass is just equal to um, weight kasi 219,333.33 divide by gravity. Since we are in SI units, therefore divide by 9.81 meters per second. Therefore, how much is the mass? Pila man ka? So, 22,358. So, 22,358. So, I hope the same mo og na-calculate na value ha. 0.138 or 14 na lang ha. Kilograms, no? Okay. So, this is now our final answer for situation number 2. Ito lang i-highlight og yellow, no? To emphasize that this is the final answer. Okay? So, be careful class kay sa problem, no? Mas ang ipangita, dili weight. Basin, ang i-answer ninyo is kanina si weight ba, no? So, kulang pa inyong answer. Kay dili man na mo ang gipangutana. Mas man ang gipangutana. Okay? Question so far or clarification? Naka-follow ra ba? I hope naka-follow, no? Wala pangutana. Pangutana mo, class. Nasabtan ra, sir. Okay, so I really hope so nga nasabtan siya. Okay? Sige, so 4:30. Okay, if we only have 30 minutes left, no, for our next topic for this session. Okay, so for the next topic now, we have another application of strain. No? So this is called the thermal stress. So I know you're familiar or you have an idea of thermal stress na, no? So this is actually a change in temperature that causes a body to change its dimension. Okay, so generally, if the temperature increases, the body will expand. Whereas if the temperature decreases, it will contract. No, so on a general note of thermal expansion, our main consideration is that if a body or if an object is subject to a high temperature, so that will expand, no? And then if it is subject to lower temperature, or in other word, bugnaw ba, no, or cold, then it will shrink, nor it will contract. So if you notice class, no, nga kana bitaw na kay sing-sing sa inyong finger, and then pag init kayo ang panahon class, maglisod mo og ibot sa inyong ring, no, maglisod mo og remove sa inyong ring from your finger. So that is because na-expand ang inyong body, no? Na siya small deformation ba, no? And if you notice nga if naka sa isa ka lugar nga bugnaw kaayo, or you are in an air conditioned nga location, so mo shrink ang imuhang finger and it is much easier to remove your ring, no, from your finger. So observe na class, no, sa inyong self. So you can have that experiment actually. So that would be our common consideration, no, here in thermal expansion. No? So if it is subject to a higher temperature, then it will expand. And if it is subject to a decrease in temperature, then it will contract. Okay, so we have here the equation or the formula, no, for thermal expansion or for thermal stress. No, so this is your deformation due to thermal expansion, and that is equal to um, deformation of due to thermal expansion is equal to alpha L times the quantity of change in temperature. No, so asa man ni siya gikan? So if you're wondering, so that is just actually derived from Hooke's law, no? So it is said that the thermal strain is directly proportional to the rate of change of temperature, no, or the change in temperature. So meaning, if we will have if we will have a mathematical expression for this, we'll have ET or epsilon of T, or your strain or thermal strain is equal to some K or constant of proportionality times the change in temperature, no? And then this K beta class, no, this only refers to your linear coefficient of thermal expansion. Okay? So your kaning constant of proportionality actually refers to linear coefficient of thermal expansion. And this linear coefficient of thermal expansion is denoted by alpha. So muna siya klase niyo makita sa equation, no? Na muna siya si alpha. So don't worry kay the coefficient of thermal expansion is given naman na siya sa mga problem class, no? Or if not, na ay table available actually class. Okay, so from this, ato lang siyang i-substitute. So alpha, change in T. No? Then recall, di ba, from strain nga ato nga topic, that strain is just equal to your deformation over your original length, no? Whereas this deformation is due to thermal expansion. Therefore, your deformation due to thermal expansion is just equal to alpha L, then your change in temperature. So, dara lang na siya gikan class. Okay? So, another concept no, of thermal stress. So, let us consider this restrained beam. Oops. So, okay, natay beam, no? Na lang. So, if this member or if this beam is subjected to a sudden increase in temperature, so normally it will expand, no? And since linear ang ato ang thermal expansion, so ang iyang expansion ana class is like this. So ako lang siyang i-exage, no, para mas ma-illustrate, no? For the purposes of illustration, so i-exage lang na ako ang drawings, okay? So it will expand like this way, no, or in this manner. But since naamang kay wall there, ano, or restricted man ang iyang expansion, meaning that wall will produce a resistance, no, or resistive force, no, and that resistive force will cause your object to have an eternal stress, no? So, mas stress na siya internally. Kaya dili man siya maka-expand, no? Dili man siya makalahos sa wall. But if we remove this wall, it will actually expand freely, no? In this manner. So, meaning, this expansion refers to our deformation due to thermal expansion or thermal stress, no? And since restricted man siya, meaning it will resist class, no? So it will have an eternal force. And that deformation refers to your deformation due to internal force, no, or due to resistive force. Okay? So ano lang siya class o. Wait, let me just move this para ano, I have space. Sige. So, supposedly class na mo di ba ni siya ang original length. Then gusto siya ma-expand kay na-increase man ang temperature, no? So it will expand, di ba? Ang ato ang basic assumption. So dili siya ka-expand kay na may wall. So meaning if wala nang wall, ma-expand siya in this manner. Di ba? So that expansion is due to your thermal stress, no? And then since again restricted man siya by the wall, so it will have an opposite reaction, no? Equal to t. Para mabalik siya sa iyang original point, which is at this point, no? So, kibali, from this point, gusto siya ma-expand up to this point, but since restricted siya sa wall, so gibalik siya sa iyang original position ba, no? So, that will have internal force or internal reaction of class. Okay? Sige. So, to better illustrate or to better understand further our concept and fundamental principles of thermal stress, let us solve sample problems. Okay, so before we will solve, no, let me just have this real-world application of this thermal stress. So, asa man nato ni siya ginagamit, no, or asa man ni siya ma-apply. No? So, naay nangutan na kaganina, no, nga if magamit ba nato ni siya sa work. So, this is one of actually this is one of the applications nato sa thermal stress sa to ang real world scenario class, no. So if you notice ang kana bitawng sa to ang mga dalan, no, sa pavement, di ba naman na siya yung mga bangag, especially ang kana pong sa bridge, no, sa iyang approach na siya yung mga spaces kibali ba, no. So kung mulabay ka nga nagsakyanan ka murag ga kung ano ba siya na kay ma-feel na mura og bump because of that kaning free spaces, no. So ginaalaw na siya class, no, or that is actually called expansion joints. So that is why nga ato na siyang i-consider because your concrete pavement, no, when subject to a higher temperature, especially na sa Philippines, no, init kaayo, so normally it will have an expansion, no, so ma-expand na siya class. So that expansion joints will accommodate the expansion, no, nga ma-generate sa imuhang concrete pavement, and that is why nga malas ang imuhang failure or ang imuhang cracks because dili sila magbangga ba, no, kay naman sila space, no. So imagine wala kay um, space na gi-allow din ha, no. So meaning um, it is subject to thermal expansion, so gusto siya mo expand pero wala siya space nga ma-expandan or wala siya space nga ma maagtuan kibali ba, no. So meaning stress kayo ang imuhang pavement, no. Then agyan pagid siya og moving loads, no. So you have vehicular loads as well as pedestrian, no, nga mga loads nga gabaklay-baklay sa atong pavement. So grabe ka stress ang pavement, no, and that will cause failure sa inyong concrete pavement. So to avoid that situation, so we allow expansion joints, no. So we allow our concrete to breathe, no. So murag muna iyahang ilong kibali pa, no. So dara siya nga area mo breathe ang inyong concrete pavement. Okay. So this is just actually one of the application of our thermal stress, but there are actually various applications pa. Sige. So let us solve this situation number 3, no, for our session today. So determine the stress for each segment if the compound bar shown in the figure. Ano sa to? Nawala ko itong gibasa. Okay. Determine the stress for each segment of the compound bar shown in the figure if the temperature increases by 100 degrees Fahrenheit. So assume that the supports are unyielding and that the bar is suitably braced against buckling. So sige. So what do you mean by suitably braced by buckling, no? So meaning class, at this support, no, or at these points, dili na siya maka-generate din na og buckling, no, or di na siya mo buckle dira, no. So meaning the stress na nga ma-develop is at this point, no, at their connection sa imong duha ka material. Okay? So sige. Let me just draw the free body diagram. Sige. So ako lang yung dakuon ang figure para ano gyud siya, makita gyud nato siya or ma-analyze gyud nato siya thoroughly. So, di ba, shallow lagi? Okay. So, this is our steel, no, nga material, and this is for the aluminum ba to? Aluminum, yeah. Sige. So, di ba, it is stated in the problem that the supports are unyielding and that the bar is suitably braced against buckling, no? So, meaning walay deformation or walay stress nga ma-develop at this point. Only at this point, no? So, meaning, if subjected to increase in temperature, no? Kaya ni-increase man daw ang temperature by 100 degrees Fahrenheit. So if ma-increase siya, so normally your materials or both of your material will be subjected to expansion. No? But since they are restricted no, at this point, dili sila ka-expand. But if ato nang tanggalon ang ilahang connection, no? So wala na to ang kaning steel, for example. So your aluminum will have a linear expansion in this manner, 'di ba? So this will be your expansion, no, for your aluminum. And then for steel, yung expansion po ana is if ato ning i-remove ang aluminum, no, so it will expand freely in this manner. Okay. So this expansion is due to thermal stress, no? And for aluminum. And then this expansion also is due to thermal stress of your steel, 'di ba? Now, but since again they are connected, meaning they will develop an internal reaction class, no, for aluminum. So dili man na siya mahitabo nga deformation, no? That's why ibalik niya at that point. So kibalik class ba no nga if ato siyang i-represent by arrows, we have this ang expansion, no, due to thermal expansion, no, gusto siya mo adtuan na nga direction. This is for aluminum, ha. And then since naaman si steel, no, gapugong. So meaning ibalik na niya, no, it will offer a resistance, no, and that resistance will cause an internal stress, no, for your aluminum. That's why napod kay deformation, no, with respect to internal resistance. Okay, ibalik lang niya at this point. So similarly, so this is deformation with respect to internal reaction, no, for aluminum. So similarly for steel, so same analysis, no, gusto siya mo expand in this manner. However, it was restricted by your aluminum material. So it will offer a resistant or resistive force that will cause internal stress sa imuhang steel. So meaning this deformation is your deformation due to internal resistance, no, of your steel. Okay, so from this figure class, no, we can say that our thermal stress is just equal to thermal expansion due to internal resistive force, no? So your expansion or your deformation in thermal expansion should be equal, no, to your deformation with respect to or due to internal resistance force P. Okay, so this is to maintain or to attain static equilibrium structure, no? So they should be equal. Okay, so we have this relationship for our deformation, no? Sige. So we have that, di ba? So again, let us analyze them separately. For steel, okay. So, di ba your deformation due to thermal expansion, di ba? You have deformation due to thermal expansion by steel and by aluminum. So, i-plus lang sila, no? from our equation, and they should be equal to your internal resistive force, no, nga deformation. S. Sige. And then recall that the equation for axial deformation, di ba? Your this resistive force will actually have a axial deformation, which is PL over AE, and your deformation due to thermal expansion sa itong equation, di ba? It is alpha L, then change in temperature. Okay? So if ato na siyang i-substitute here, you'll have deformation due to thermal expansion for aluminum. So this is alpha length change in temperature for aluminum plus your deformation due to thermal expansion for steel. So alpha L times the change in temperature for steel is equal to um, deformation due to axial deformation, no? Or due to axial resistance nga force. So CPL over AE forced aluminum plus your resistive force nga deformation for steel. No? So ato lang siyang panganlan class para di maglibog ba no kay same equation lang baya. So masin malipat ba og substitute sa values. Sige. So let us have this for aluminum. So our alpha no is 12.8 times 10 to the power of negative 6. So, di ba, unit nga is per Fahrenheit times length. Original length no of your aluminum is 10 inches times the increase no in temperature, which is 100 degrees Fahrenheit. So, di ba, this is in degrees Fahrenheit. So, meaning mag-cancel out lang ni siya, no? The unit for your coefficient of linear thermal expansion is nakaano man siya, no? Per degrees Fahrenheit. Okay? So, this is for aluminum pa lang, no? Now, for steel, plus alpha or the coefficient of linear thermal expansion for steel is 6.5 times 10 to the power of negative 6 times the original length of your steel is 15 inches times the change in temperature, no? So, for steel, po ni siya, is equal to, so for aluminum, you have PA, which is ano, no? PA, actual load no for your aluminum is still unknown. Then original length of aluminum is 10 inches, diba? Divide by the cross-sectional area of aluminum. So 2 inches siya. Times the modulus of elasticity for aluminum, and that is 10 times 10 to the power of 6, no? PSI. So this is for aluminum plus for steel. So sumpay lang ni siya class, no? Di na siya maigas akong space. So for steel, you have PS, no? Which is unknown still. Original length of steel is 1.15 inches rather. So this is times 15 divided by the cross-sectional area of steel na 1.5 inches squared times the modulus of elasticity for steel na 29 times 10 to the power of 6 psi, no? So, if you notice that the left side of our equation will have constant value, no? Kaya wala may unknown variable dira, di ba? So, kindly solve for this class. How much is this? Oops, ano yun siya? Kindly input sa inyong calculator. So, you have so pila siya ka decimal place, no? At basin ato na siguro i-consider tanan if gamay lang. 0.023. So, ang others, nganong naglahi-lahi man mag value mo, same raman yung o values, no? Okay, so you have here 0.02255. Sige. So, the left side of our equation will yield 0.02255 equal to, so kindly solve for this one class. No? So, ano siya, no? 10 divided by 2 times 10 times 10 to the power of 6 in terms of PAL. And also solve for this one. Kindly calculate. So you have 5 times 10 to the power of negative 7. So 5 times 10 to the power of negative 7 PAL plus for AS, I mean for steel class. Pila man niya siya? 3.448 times 10 to the power of negative 7. Sige. So, times 10 to the power of negative 7 PS, diba? So, we have this equation. Now, let us determine if in terms of P, how much is the resistive force of steel and aluminum, no? So, di ba we have this figure? And if ato na siyang i-cut into segment, no? If magkat og section, so this yellow line, sakit kayo siya sa mata, kadali siya. Okay, sakit kayo akong mata. Wait lang, ako sa siyang i-change into darker color. Kani siguro blue. Sige. So, from this section class, no? Diba, that is for aluminum, no? So, ma-express na to or ato ang mapagawas ang internal reaction no, for your aluminum. Kaya gikat man na to si aluminum. So, meaning, with respect to support na si P, then gikat na to ang aluminum. So, ma-expose ang iyahang internal reaction nga si PAL, no? Meaning, if mag-sum up the forces on x-axis, P is just equal to PAL, no? For steel. How about for steel? So, this is, wait lang, ato lang siya ilayo gamay. So, for P, or reaction no at your support, and then, muna si aluminum, and si steel, no? And gikat na to si steel para ma-determine na to yung internal reaction. So, if mag-sum up to of forces on x-axis, still, P is just equal to PS, no? Therefore, ato lang ni siyang i-let, no? Kani si PAL and si PS equal to P. So, meaning, If that is the case, then masolve na nato ang value for P, di ba? So how much is P class? Using this equation, therefore P is how much? 26,692.708. So 26,692 pounds. Okay? But, dili pa ni siya mao ato ang final answer class, no? Kaya ang sige pangita sa problem. So, stresses, no, for each segment. Then, di ba we have an formula for stress? Stress is just equal to P over A. Therefore, given naman si cross-sectional area, gipangita si stress. So, ang atong problem lang is si P, no? In which we have obtained P already. So, for our final solution, we have the stress, no, for your steel is just equal to P. Di ba ato ang PS, no? It should be PS man. PS is over AS, no? But since from this equation, PS is just equal to P, di ba? Therefore, ato na siyang gamiton directly. So, you'll have 26,692.708 pounds divided by cross-sectional area for steel. And how much is our cross-sectional area for steel? 1.5 inches squared. So, pound per inches squared, that is PSI, di ba? So, therefore, your normal stress for steel is pila man ni siya? 17,795. 17,795 point, ano to siya? 139. 139 PSI. Okay. So, for aluminum naman, same procedure, no? So, for aluminum, you have PAL over AAL, in which from this relationship also, your PAL is just equal to P. So, directly nato na siya i-use, no? Ang value sa imong P na 26,692.708 pounds over the cross-sectional area of steel. And how much is the cross-sectional area for steel? Sorry, aluminium day, no? You're solving for aluminium. So 2 inches squared. And divide by 2 inches squared. So pound per inch squared is PSI. So your normal stress for aluminium is 13,346.354 PSI. Okay. So these are now our final answers, no, for situation number 3. Okay, ang pangutanan lang man is determine the stresses, no, for each segment. So let me just check my reference, no, if sakto ito ang answer. So for normal stress of aluminium, we have 13. The final answer is 13,345.88. So sa ato lang siguro rin siyang pag round up, no? And then for steel is 17,795. Tama. Okay. So, sakto ato ang answer, no? So, yun sa gali pagkuha. Ang 26,692.78, sir. Actually, dari lang na siya class, no? Atong gi-expose kibali ba, no? So, atong i-express si PL in terms of P. Kaya wala man tayo other equation. So, to do that, atong gi-cut ang segment, no? Nag-cut og segment kang aluminium to expose the internal reaction of aluminum, no? So since P is acting this way or yung mga support is this way, so your internal reaction at aluminum is directed that way also. So meaning P is just equal to PAL, no? Kaya wala may line force involved as well as for steel, no? So P or reaction lang at support, then your internal reaction is PS, no? Is just equal to P. Kaya wala man tayo force involved or acting at this point. No, recall from our first discussion on stresses, no? Di ba nakasolve ta og stresses in bars or compound bars like this? So same lang siya actually class. So nag-cut diba tawag segment to expose the internal reaction at that material. Okay? So any other question? So wala question? Wala na lain? Sorry no, nag-extend na to 4 minutes. Sige. Wala na question class or clarification? Okay. So if wala mo clarifications or question, no? So let me just have your attendance. So say present if you're here sa meet. So today is March 28. Sige. So Aberin Monique, Abrenica Hannah Grace,
Present, sir.
Asibar Maria Christine, Baconga Lloyd Vincent, Pastatas Joby.
Present, sir.
For a while ha, kay. Hindi na ako makita akong screen. Okay. So Bayotas Monique Grace,
Present, sir.
Beniga Janiel Rose,
Present, sir.
Bonglay Joey,
Present, sir.
Kailing Joby,
Present, sir.
Econor Dondi, Jeffrey James,
Present, sir.